Alright, hello. We are going to be doing model problem 3. It's on page 18 of your notes. You should be able to see it on the screen. It says, find the volume of the solid whose base is the region in the xy plane bound by the curves y equals x squared and y equals 8 minus x squared, and whose cross-sections are perpendicular to the x-axis. They're going to be semicircles, and the diameter is lying in the plane. So first thing, we always want to do our visual, so go ahead and get your notes out if you haven't already. Okay, so for this problem, it says we have two functions here. We have our just x squared. Everybody should know what a quadratic looks like. U-shaped opening up. So that's our y equals x squared. They also told us we have y equals an 8 minus x squared. Whenever we see that negative in front of x squared, we think, okay, it's reflected, so it's opening down now. And when we have a positive 8, that means it's been translated up 8 units. So what we're going to say is, okay, up here at 8, that is where my graph is starting, and it's opening downwards. So it looks like so. So what we're worried about is a solid with the base in this shaded region here. We need to find these intersection points. Remember, to find intersection points, all we're doing is setting them equal to each other. This is how we determine our bounds for our graph, since there weren't any given. So if I have an x squared equal to an 8 minus x squared, to solve this, all you're doing, add your x squared over here, so we have 2 of them now. Divide by the 2, and then take our square root. So positive and negative 2. I'm not worried about my y values because we're looking at this in terms of our x. So what we're going to do is just say, okay, I know this is a negative 2 and this is a 2. I know what my bounds are now. Next, we're going to finish up this visual. We're going to say, okay, well, if I have a chunk that I just cut out here that looks like this, well, that distance here, that's dx. And if I pull that chunk out and flip it on its side, well, it says we have semicircles. So our graph here would have this coming out of it when we slice it. If you want the 3D visual, it would look something like so. Here, this is the dx we cut out. Now we need to figure out what our L is. Well, our L, it says this diameter was on our plane. So that's our L. And if L was on the plane, it's going to be the top function minus the bottom function. So we're going to have an 8 minus x squared minus our bottom function, which was another x squared. So we know L is equal to an 8 minus a 2x squared. What we need to do with this is say, okay, what would the volume be of one of these cross sections? So I'm going to write that over here. Our volume of one of these cross sections, well, if I want to know the area of this semicircle, I need my radius. So it's going to be 1/2 L. So we have a 1/2 L, that's my radius. So volume, we need the area of that semicircle. So 1/2 pi r squared, so r squared. We also have a pi over 2. Now, for my width, that's dx. When we write this as the volume of our solid here, now we need to apply our integral because we're looking at the area of this entire base with those semicircle cross sections. We're starting at negative 2 and we're going all the way over to positive 2. So that's our bounds over here, negative 2 to positive 2. We're going to plug this function in. 1/2 L squared. Well, if I'm going to replace L with what it's equal to, 8 minus a 2x squared. So we have a 1/4, because that's the 1/2 squared. So I'm going to pull that out. And then L squared in this case here is 8 minus 2x squared. Then we have that other pi over 2 dx. Well, since these are both constants, I can combine those in my next step. I'm also going to expand this. So now we're going to have the integral from a negative 2 to 2 of a pi over 8. And that's times an 8 squared, 64, minus 2 times what these are multiplied together. So what I'm saying is 8 times a negative 2x squared, that's a negative 16. If I multiply that by another 2, that gives me my middle term here. So I'll have a negative 32x squared. And our last one is this negative x squared squared. So I plus 4x to the 4th. And then our dx. From here, it's just taking our integral. Remember, our constants just follow along with us. That's just going to come down. And we're going to do the power rule for each of these terms. So this is going to be a pi over 8. Remember, we can drop that integral symbol now that we're actually taking our integral. We're going to have the 64x minus, now I increase that x squared by 1, so x cubed, bring that down into the front, so a 32 thirds, plus increase that by 1, x to the 5th, 4 fifths in the front. And then this is evaluated from a negative 2 up until 2. So take a second to catch up if you need. Go ahead and pause it now. Now we have a bunch of simplification to do here. We're going to plug our 2 and our negative 2 in first. So what we're going to have is a pi over 8. And if you remember our rules for our even functions, what it says, if it's an even function here and it's symmetrical on both sides, is it's really just that top function, evaluate it, and multiply it by 2. So I'm just going to add a 2 in the front and plug 2 in here. So what that's going to do is make this a lot easier to simplify. We have a 64 times 2 minus a 32 thirds times a 2 cubed plus a 4 fifths 2 to the 5th, like so. If you don't believe me that this is just multiplied by 2, I have the work over here. So if you want, you can pause it and look through that. This is me going through and saying, okay, I evaluated this at 2, I'm evaluating this at negative 2, and this is where we're going to get. So here we have our pi over 8. That's going to be multiplied by 2. Oh, sorry, I forgot to combine these. So it's going to be a pi over 4, pi over 4, because those will cancel one of those 2's out. Multiplied by, we're going to have a 128 minus a 256 over 3 plus a 128 over 5. Now, not the nicest numbers, so I went ahead and plugged them into my calculator. But you could do this by hand. You would just multiply by 5 over 5 here, and then by 3 over 3 here. And then here, 15 over 15. Gets kind of big. But when you divide by this 4, that helps out a lot. So, if you wanted, you could divide by 4 first, and then try and combine them. When you do that, you'll end up with a 256 pi over 15.